Good to go.
Okay, thank you. Myself, I'm Gabriele Paoloni. I work for Red Hat, as you can see. And within ELISA, I'm the chairman of the governing board, as well as the lead of the safety architecture working group. And today, I'm here to give you the annual updates about the architecture working group. Okay. Good. So the agenda for today, I will first give you an introduction about the working group. Then we'll look at the past year's activities and milestones. We'll talk about the current focus, and then we'll see what is coming up in 2026. And we may have some discussion for areas and opportunities for collaboration. And then, I will tell you how to join the working group meetings, basically, and how you can get involved. Okay, so what's the mission of the working group? As defined in the ELISA website, according to technical safety requirements produced by domain-specific working group, the focus of the architecture working group is to determine critical Linux subsystems and components in supporting safety function, define associated safety requirements and scalable architectural assumptions, deliver corresponding safety analysis for their individual qualification and their integration into the safety critical system. Now, it's a pretty lengthy statement. What does it mean? So the mission is basically to analyze how the different Linux kernel subsystems can be used to support safety requirements that are generated from an higher level application, like from, for example, from the automotive working group or another working group. And at the beginning, we started doing this like a few years ago. And then we realized that, it was pretty hard to keep analyzing the kernel because we were missing mainly, to start with, we were missing the requirements associated with different functionalities provided by different subsystems and drivers that are part of the kernel itself. And so, I think now more than a year ago, our main focus has been figuring out how we can introduce software requirements as part of the Linux kernel development process. Okay. So, and in fact, what we did as part of the past year activities, we looked into the Linux kernel requirement framework definition. We looked at the integration of the strict doc tool as a way to maintain these requirements and to trace these requirements to corresponding tests. And indeed, we started, some trials. We started some trials to upstream code specification and associated testing. Okay. So then, to start with is, why documenting the code is important. Okay, so this was initially raised at Linux Plumbers 24. And indeed, there are different reasons why we need code documentation. Okay. First of all, new developers and security experts can verify if their proposed modifications are coherent and consistent with the intended behavior. And we would have a reduction of incorrect or buggy patch proposal by new contributors. And tester can test if the code testers can test the code against documented behavior and documented constraints of use, because otherwise, if you start from the code, you don't know if a certain code behavior is intended or it is a bug. You cannot distinguish between a bug and a feature, really. Right? So in general, the goal is to reduce the technical debt associated with leaks. Okay. So here you can see that we started drafting this template for requirement descriptors, effectively. We have basically a unique requirement ID. Then we have a requirement text that is the semantic description of the requirement. We have a tag that marks the end of the requirement. We have a tag for marking code that contribute to a certain requirement. Another one for note. Another one for hash key to basically flag if requirements or code have been modified. We have another tag for requirements child to enumerate lower level decomposed requirements, and finally for requirement sys to identify the subsystem or driver that is associated with a certain requirement. Okay, and this is what we put together in the working group, what we've been discussing, and for some of these fields we identified these to be put in line with the code, or for other fields we thought that this should be placed into sidecar file. Okay, and well, good. So there is nothing special, with this table. And according to this table, we also work together with the Linuxtronics mainly, that proposed to introduce to integrate the strict.doc tool to maintain requirements according to the table of requirement format that I presented in the previous slide. Okay, and okay, here you have an introduction of this strict.doc tool, and the main goal is to basically associate atomic nodes to code and requirements, associate them with the unique ID and attributes, and link them together in a sort of traceability graph. Okay, indeed, traceability between requirements, sub-requirements, and corresponding test is a very important property for maintaining a consistent quality case for software. Okay, and here you have everything that you need to look into the current work that's been done for the strict.doc integration. And basically here we are looking into an example where what you see on the top, it is an example of requirement with a requirement ID, requirement text. This is the function that has been defined, trace set clear event with the function's expectation. Then we have the end of the requirement, and then we have the implementation of the function. So this is in the Linux kernel source code. Okay, this is intended to be there. And below we have the sidecar for this requirement that is digested by strict.doc to generate an HTML view, effectively, that you can see here. Okay, that is much more human readable and human. It can be navigated by a human, right? So you click here on the different requirements that you are interested in, and you can look at each of these, and these can be also eventually traced, to corresponding tests. Okay, so this is what we have been exploring with this strict doc. And you can see here, yes, actually an example of traceability graph between readmem and then readmem FE-1, that is a function expectation. So it is a sort of sub-requirement, and also there is the corresponding test here, right? So we have here in this case, we have a self-test that has been developed. This is based on a patch set, an RFC that we proposed upstream. Okay. Okay, good. Now this is now I talked about the SPDX. Sorry, I talked about the strict doc integration. Indeed, the most important part, however, is proposing these requirements upstream. Okay, so initially, we started, to put together requirements according to the format that I presented, and the main suggestion that we got from Steven Rostad, that is the maintainer of the tracing subsystem, was, okay, good, but before refining further such syntax, please work on the semantics and show the value. Okay, so when it comes to the upstream contribution, we did follow this suggestion. So we stepped back from this requirement formalism. We didn't put any SPDX rec, any of this tag, and we started doing some submission. And when we started doing this submission, first, we found a bug that was fixed. This is the patch that I sent out and was accepted. And so it is effectively useful to do this activity. And also, there was a redundant flag that was spot in the code. And in fact, Steven, he did rework, the code following our finding. Okay, and you can see here, another patch that Steven sent out. And indeed, also what we did is we submitted a patch set with the documentation, testable expectation, and associated test upstream also for dev-mem. Okay, so we want to define semantically how requirements should be written. Okay, only from a semantic point of view. And however, the feedback was not very good. Okay, so you can see here that this is the feedback from Greg Roharman in the mailing list, and he said explicitly, you're entering into a path that never ends with no clear goal that you are conveying here to us, and is saying, do you want every in-kernel API documented in a formal way like this, or a subset? If a subset, which one specifically? So there was a skepticism. And now, after this, I went to Linux Plumbers, okay, in 2025. Sorry, there is a typo here. I need to fix it. So at Linux Plumbers 2025, I talked to Greg, okay, and he suggested for his specific patch set to remove the formal guideline on how to write requirements and submit code specification, and and instead, he said, please, just submit the code specification and test according to the current kernel doc and KUnit formalism, okay, without adding, more formalism. And also, we had a discussion with different maintainers, the Paul McKenney, Julia Laval, Mark Rutland, to mention some of them. And we collected some feedbacks, okay? The first feedback was that, they have a concern about the effort of maintaining low-level specification and tests versus the real gain from introducing them. And also another point that was raised is that specification written in natural language could be interpreted differently by different contributors. And this is also depending on the language proficiency, And the final one is that kernel API tests may not be sufficient and should be complemented by architecture level tests. For example, especially Julia Laval is doing a lot of work for introducing, formal model verification in the Linux kernel. Okay, so this is a verification method that is very much suitable for, especially for verifying the interaction, between different components, rather than for verifying a single function. And this aspect is also very, very important and complementary with respect to kernel API tests. Okay. So then what do we do following these feedbacks? Right now, our top priorities are these ones. Okay, so the first one is to keep working on upstream contributions, devmem, and tracing subsystems in the very short term. Then we need to continue to show value in introducing requirements and specification and testing. So basically, we need to find and fix bugs. And the last one is we need to define a maintainable framework and an associated development process. Okay, a big concern from the maintainers was who is going to maintain, these requirements and test. What is the effort behind this? And here the goal is, to show that if there is a proper framework with a respective automation, it will be indeed maintainable, right? Also, if there are companies with the best interest, to maintain requirements and tests, it will be a plus, right? So basically, if the maintainer is not alone, in maintaining, requirements and testing. So what's coming up then in 2026? First thing is practically we need to get the current upstream RFCs accepted. And I'm doing this personally, to be honest. We need to find the new subsystems that may be more bug prone, so that, and for this, we can show, bug reduction when implementing requirements and associated tests. And also, we need to keep working on the strict doc integration to have a maintainable framework. Okay, so I think that, I'm working, with Tobias from Linuxtronics. I think that, strict doc may be a viable solution, to address the concern of maintainability. Okay, and finally, but this is very long term, to be honest, at the end of the year, maybe, we need to start defining a requirement, development, and maintenance workflow for the Linux kernel upstream process. Okay, this is really the hard part, because in order to do this, we need first to convince the maintainers that we are bringing value and that this value is effectively maintainable with the current um, set of maintainers that we have. Okay, and yeah, so last slide is how to get involved. You have all the information here. I can tell you already that our weekly meetings, so we have weekly meetings, and they happen on Friday at between 4 and 5 p.m. Central European Time. Okay, so if you want, to join our effort and to understand better what we are doing, please help us. And yeah, finally, I want to give a special thanks to Kate Stewart and Chuck Wober that have been really major contributors into this effort of defining requirements for the Linux kernel. Maybe we have a couple of minutes for questions.
Raise your hand if you have a question. I'll unmute you.
So, Gab, you will meet again on Friday, I guess.
Yes.
Yeah.
Yep, the safety architecture working group meeting is on our calendar. I dropped the link on chat. You'll see the meeting on Friday, the 13th, this week. You just click on that meeting and click on register. It'll send you a calendar invitation. It's very easy. We make it as low barrier as possible for people to get involved and collaborate.
In the rare case you cannot see the calendar, which can happen for a minor version of long-term support version, extended support versions of Firefox, just change to another browser engine or open it on your mobile, then it will most likely anyway work. Cool. I guess